Okay, so we're going to look at number 1 here. Dale has a special deck of cards. Each card has a different rational number on it. The cards are 25 hundredths, 4 fifths, 2 ninths, 48 hundredths, and 8 elevenths. They want to know how many cards have a value that is greater than 1/2. Well, the first thing I'm going to do here is I'm going to convert 1/2 to a decimal. I would divide my numerator by my denominator in my calculator if I wasn't sure, and that is 0 and 5/10 is 1/2 as a decimal. So now I have 25 hundredths here, 4 fifths, 2 ninths, 48 hundredths, and 8 elevenths. So now what I'm going to do is find the decimal equivalent of each of these. Well, 25 hundredths is already a decimal, so I'm going to leave it. 4 fifths as a decimal, 4 divided by 5 in my calculator, I'm going to get 8/10. And then we have 2 ninths as a decimal. So that one in my calculator, 2 divided by 9, is, I'm going to round it to the thousands. There we go, 222 thousandths. 48 hundredths is already a decimal. And then I need to take 8 divided by 11 to get 8 elevenths as a decimal. That is going to round to 727 thousandths. So now I'm going to line these up by place value and decimal point. I'm going to fill in my zeros where I need to fill them in. Okay, so I'm looking for any number greater than 0 and 5/10. Well, I don't have anything to compare in my ones column here, so that doesn't help me. So now I'm looking at this column here, my tenths place. I'm looking for any number greater than 5. So here's one, and here's one. So they want to know how many cards are greater than 1/2. The answer is going to be C, 2, because 4 fifths and 8 elevenths is greater than 1/2. So there you have it. Now if we go to number 2 here, they want to know what set of rational numbers is ordered from least to greatest. Well, if I'm on a number line, here's 0, here's -1. Halfway between is -5/10, right? Here is going to be -48 hundredths, and about here is going to be -45 hundredths, right? So I know that 48 hundredths, -48 hundredths, if I'm looking at this column, is further to the left. So that is least. That's the smallest number. So then I can get rid of C. That can't be it. I can get rid of D. That can't be it. So now I need to move to this next column. It's nice that these are all lined up for you. You can look at them pretty easily. And here I have 47 hundredths and 46 hundredths. Well, 47 hundredths is going to be closer to 48 hundredths than 46, so it can't be B. My answer has to be A. So there's number 1 and number 2, and the work that should be involved in trying to figure out those 2 answers. Okay, let's look at number 3. So number 3 says, which number line shows the correct placement of the points above in the table? Okay, so what we have to do is look at these values. We have -31 hundredths, -33 hundredths, -38 hundredths, -29 hundredths. Well, you can see each of the number lines goes from 3/10 to 4/10. So that means that halfway between is going to be -35 hundredths. And then that means that 38 hundredths, -38 hundredths, is going to be about there, right? So then -33 should be about here, -33 hundredths. -31 is going to be about here. And then -29 hundredths should be here. So we need to find one that lines up with that. So if I look, D Negative 29 hundredths. Oh, it is on that side, right? So that's good. Then I go to A, negative 31 hundredths. So there it is. It's right after. Okay. Then I can go to C. Okay, C is right here by negative 4/10. So you need to find the number line that matches up best with that first option. So your option here is going to be A. It's the only one that will work. Okay, this problem says Kendra placed the numbers negative 3/8, 27 hundredths, negative 3/10, and 4/7 on the number line. Which of the numbers is furthest from 0? So the best way to solve this one is to convert all of these fractions into decimals. So my first number is negative 3/8. Negative 3/8 is equal to negative 375 thousandths as a decimal. Then we have 27 hundredths. It's already a decimal, so we're going to leave that one the way it is. Then we have negative 3/10, also already a decimal. And then we have 4/7. So, oops, get rid of that. And then 4/7, and that is equal to 0 and 571 thousandths. So what I need to do now is look at these because it says which one is furthest for 0. So that should tell you that you're looking for absolute value because you're looking for a number that's farthest from 0. That's the distance from 0 on a number line, okay? So really, you're looking for the biggest number as far as absolute value goes. So the absolute value of negative 3 and 75 hundredths is 3 and 75 hundredths. The absolute value of 27 hundredths is 27 hundredths. The absolute value of negative 3/10 is negative 3/10. And then the absolute value of 5 and 71 hundredths is 5 and 71 hundredths. Or, I'm sorry, 571 thousandths. Sorry about that. I was writing and talking at the same time. So then you're just looking, which one of these is the biggest number, right? Which one's the biggest? Well, I know if I line these up by decimal point and place value, and fill in my zeros, now I can compare. Okay, I don't have anything in the ones to compare, they're all zeros. Here's my tenths. Okay, you have a 3, a 2, a 3, and a 5. Oh, that is definitely the biggest. So the number with the largest absolute value is 571 thousandths, which goes with, right here, 4/7. So my answer is D, 4/7 for this one. Okay, so I hope that made sense. Okay, I'm going to erase this, and we're going to talk about number 5 real quick. So this one is saying Mandy divided a 12-pound bag of oranges into 5 equal piles. What rational number represents the weight of the oranges in each pile? So this is where you should label your fraction. So I have 12 pounds divided by, because remember the fraction line means divided by, 5 piles, right? Now I'm not going to take my piles and divide them by pounds. I'm not going to take piles and say, here orange, here's a pile, right? That wouldn't make sense. But 12 pounds of oranges put into 5 equal piles, I can then get the weight of each pile. So I'm going to take 12 and divide it by 5, because 12 divided by 5. 5 goes into 12 twice. 2 times 5 is 10. I subtract 12 from 10, I get 2. 2 is my numerator. 5 is my denominator. My unit is still pounds. 2 2/5 pounds The answer is D. Okay. Okay, we're going to look at number 6 here. So we need to know which statement is not correct. Not correct. Okay. So we're looking for the one that does not belong. So first of all, let's start with all rational numbers are also integers. So to check that one out, I'm going to draw that Venn diagram. So here's my whole numbers. You know, those are all positive, like 1, 2, 3, 10, etc. Then we have integers. Integers are made up of all whole numbers and their opposites. So we're talking 1, -1, 1, -2, 2, 0. Okay. Then we have rational numbers. In there, you're talking about like mixed numbers, negative decimals, and also all whole numbers, their opposites like integers too. So this is the rational. You have this in your notes. So a whole number is an integer, which is also rational. So if it's a whole number, it goes in all 3 categories. Then, if it's an integer, it's negative or positive, or the opposites. Okay. So if you're a whole number, you're an integer. If you're an integer, you're also rational. However, you can work your way from the inside out, but you can't necessarily go from the outside in. So not all rational numbers are integers. Okay. It's like 1.5. It's rational, but it's not an integer because it has that fraction. -3 and 12/100ths, that is rational, but it can't be an integer because it has the decimal. Okay. So I'm feeling pretty good about A is the right choice. Let's just explore the other ones. 0 is a rational number. Yes, it is. It's true. It's a whole number. It's an integer. It's also rational. All integers are rational. Yes. I can go from the inside out. So all integers are also rational. That is true. And all rational numbers can be written in AB form. Yeah. If I have 1 1/2, I'm going to take 2 times 1 and get 2. Plus 1 is 3/2. That's AB form. Okay. I can say -3 and 12/100ths is the same as -3 and 12/100, which is the same as -312/100. Also AB form. So the correct answer to this question is A. Okay. Now, let's look at number 7. Get rid of this. Mumbo jumbo. So number 7 says, Philip wrote the numbers 3 and 1/5, 3 and 1/7, 5 and 1/8, and 1 and 5/6. They want to know the biggest numerator he wrote because these have to be in AB form. So all I'm going to do is take all of these mixed numbers and turn them into improper fractions. So 5 times 3 is 15, plus 1 is 16 over 5. 7 times 3 is 21, plus 1 is 22 over 7. 8 times 5 is 40, plus 1 is 41 over 8. And then 6 times 1 is 6, plus 5 is 11 over 6. I'm looking for the biggest numerator, so I'm looking at the top part of my fraction, numerator, and the answer is 41D. Okay. Let's look at number 8 here. So Dory claims that 3 and 52/100ths is not a rational number because it isn't written as a ratio of integers. Is she correct? Well, a ratio of integers, that's AB form. Okay. So is she correct? Well, the answer to here is no, she is wrong. Here is why. So 3 and 52/100ths, this is the same as 3 and 52 over 100. And then I can turn that into AB form by saying 100 times 3 is 300, plus 52 is 352 over 100. So that is AB form. It can be written as a ratio of integers. So your answer is no, she is incorrect. 3 and 52/100ths equals 352 over 100. So it is rational. Okay? So So I hope that makes sense. Let's take a look at number 9. Number 9 says, 4 runners ran the 100-meter dash. The times are shown in the table above. Which runner had the fastest time? Well, when you think of this, you need to think about the fastest time. So if I'm running in a race and I run it in 7 seconds and you run it in 10 seconds, I finish first because 7 seconds comes before 10 seconds. That means I'm faster. So here we're looking for the lowest number, okay, for the fastest time. So they're already lined up by decimal point and place value, so you don't even have to do that part of the work. So I'm going to look at my whole numbers. They're all 12s, okay? That doesn't help me. Now I'm looking for the smallest number in the tens place. Well, I have 3 4s and a 5, so that one can't be right. That's the slowest. So now I need to move to my hundredths, and I'm looking for the smallest number. So I have a 5, an 8, and a 4. Oh, 4 is smallest. So Shelly is the winner of the race. Okay. Okay, let's look at number 10. Number 10, we have, write the numbers -2 1/10, -1 5/6, -3 2/3, or I'm sorry, -1 2/3, and -2 2/10 in AB form from greatest to least. So I'm going to make my list over here. So I have -2 1/10. I have -1 5/6. I have -1 2/3. And I have -2 2/10. Now they're all negative numbers. Okay, so that's really important information here. So the first thing I'm going to do is take 2 1/10 and turn that into a mixed number. So that's going to be -2 1/10. Okay. Then I have -1 5/6. I'm going to bring that down. I have -1 2/3. I'm going to bring that down. And then I'm going to turn -2 2/10 into a mixed number. There we have it. Okay, now I'm going to turn all these mixed numbers into AB form in proper fractions. So 2 times 10, that is 20, plus 1 is -21/10. Then I have 6 times 1 is 6, plus 5 is 11, so I have a -11/6. 3 times 1 is 3, plus 2 is 5, -5/3. And then I have 2 times 10 is 20, plus 2 is 22, so it's -22/10. So now they want us to list these in order from greatest to least, okay? Well, I already know that this -21/10 is the same as -2 1/10, okay? And I already know that -22/10 is the same as -2 2/10. These ones have 1 for their integer. So I'm going to draw a number line. Here is 0. Here's -1. Here's -2. Here's a positive 1. Now, I know that -2 1/10 and -2 2/10 are going to be here, right? So this is -2 1/10. This is -2 2/10. Okay? So now I'm left with -1 5/6 and -1 2/3. Well, I can easily turn those fractions of my mixed number into decimals. Okay? So -11/6, I can even just take 11 and divide it by 6 in my calculator. Okay? And when I do that, I'm going to get -1.833. -1 and 833 thousandths. And then if I take 5 divided by 3, I'm going to get -1 and 667 thousandths. Okay? So I'm going to put those on this number line. Okay, so this one's going to be about here, -1.833, and this one's going to be about here, -1 and 667 thousandths. Okay, I want them greatest to least. So my greatest number here is the one closest to 0, and that is this one right here, because it goes with this decimal. So -5/3 is the greatest. Then -11/6 is the second greatest, because this 1 and 833 thousandths goes with that number. Then it's going to be -21/10, and then -22/10. So that is my final answer in AB form from greatest to least. Okay, hope that makes sense. All right, let's look at number 11. I'm going to switch to red for this one. So number 11 says, which lettered points in the number line above have an absolute value less than 3? So you have to remember that absolute value is a number's distance from 0. Okay, so if it's negative, it can be positive. Then, because I'm only taking the distance from 0, I'm not doing negatives or positives. So absolute value less than 3. Okay, so this point A is past -3, so its absolute value is going to be more than 3. Okay, then if I look on this side of my number line where 3 is, okay, this one is also past 3, E. So that absolute value is going to be greater than 3. So I need all the letters that are in between -3 and 3. Okay, so that's going to be B, C, and D. Because the absolute value of those, when you take it, is going to be less than 3. Okay, let's look at 12. 12 says if x is a rational number and y is the opposite of x, why do they have the same absolute value? Well, guys, what's absolute value? Absolute value is a number's distance from 0, right? So if x is rational and y is the opposite of x, they have the same absolute value because those numbers are the same distance from 0. So if you weren't sure about that, plug in a 5, right? So if x is 5, then y is -5. Why do they have the same absolute value? Because they're both 5 units away from 0. So your answer to this is just, there's the same distance from 0. Okay. All right, so let's look at number 13. Number 13 says, the table shows the daily temperatures for a 4-day period in Chicago. Which temperatures were lower than -1.5 degrees Celsius? Well, I'm going to draw a number line. Okay, and here's 0, here's -1, here's -2. That means that this is -1.5, right? And I'm looking for any one that is lower than this right here, okay? And I'm going to make that point yellow. Lower, meaning it is colder than -1.5. That means it's going to have to be to the right, or I'm sorry, to the left of -1.5. Well, if I look at, I'm going to go to light blue for these, -1 2/10, that's going to be about here. That's not to the left, right? If I look at -2, oh, that's going to be here. That is to the left. So -2 for sure is lower. Then -1 8/10, that's going to be here, still to the left. Okay, that one is lower. -1 8/10 degrees Celsius. Now, -1 4/10, oh, that's on the right side. Okay, so that is not lower. So what days was the temperature lower than -1.5 degrees Celsius? Tuesday and Wednesday. Okay. Okay, 14 says, explain how to write the rational number 3 21/100ths in AB form. We just did one like this. So I'm going to take 3 21/100ths. I'm going to turn that into a mixed number of 3 21 over 100. Then I need to create an improper fraction. 100 times 3 is 300 plus 21 is 321 over 100. AB form right there. Okay, finally, number 15, Kevin compared the absolute values of negative 2 1/8, negative 2 2500ths, 2 3/8, negative 2 2900ths, and 2 4/11ths. Which one has the greatest absolute value? So you're talking about numbers distance from 0. It's going to be a positive number here because we're just measuring the distance from 0. So I'm going to take negative 2 1/8, negative 2 2500ths, 2 3/8, negative 2 2900ths, and then I have 2 4/11ths, and I'm going to convert them all to decimals. So if I take 1 divided by 8 in my calculator, I'm going to get negative 2 125 thousandths. Negative 2 2500ths is already in decimal form. Then I'm going to take 3 divided by 8 to convert this 3/8 to a decimal. And that's going to become 2 375 thousandths. Okay. Then I already have negative 2 2900ths as a decimal. So I need to convert 4/11ths. 4 divided by 11 is 2 363 thousandths. So I'm looking for the greatest absolute value, meaning numbers distance from 0. So I need these to all be positive, and I'm going to line them up by decimal point and place value because absolute value is a number's distance from 0. So I have 2 125 thousandths, 2 2500ths, 2 375 thousandths, 2 2900ths, and then 2 363 thousandths. I'm going to fill in my zeros. Now I'm looking for the biggest number. All of my whole numbers are 2. That doesn't help me. Now I'm going to my tenths. I have a 1, a 2, a 3, a 2, and a 3. I'm looking for the biggest number, which is 3. That means these ones are out. So these both have 3 in the tenths place, so I need to go to the hundredths. Oh, right there. 2 375 thousandths is the biggest. I'm going to look up here. What one does that go with? Okay, it goes with 2 3/8. 2 3/8 has the largest absolute value. Okay, so there is a review of this test. I explained every question in 28 minutes. So you should be able to make any corrections or retake this test that you need to make in order to get a better score. Okay, thanks guys.